In this video, you will learn about conditional probability. What is conditional probability? Conditional probability is the probability that an event, for example, an event Y will occur given that an event X has already occurred. It is denoted by the symbol read as the probability that Y occurs given that X has occurred, or simply the probability of Y given X. It is further defined by the equation the probability of Y given X equals the probability of the intersection of X and Y over the probability of X, if P of X is greater than 0. Let's apply the concept of conditional probability. Let's take this as our example. The probability that a plane departs on time is P of D equals 0.83. The probability that it arrives on time is P of A equals 0.82. And the probability that it departs and arrives on time is P of A and D equals 0.78. Now, let's find the probability that number 1, it arrives on time given that it departed on time. And number 2, it departed on time given that it has arrived on time. How are we going to solve this problem? First, we need to list all the given. That is why we have P of D equals 0.83 to represent the probability that the plane departs on time. P of A equals 0.82 to represent the probability that the plane arrives on time. And P of A and D equals 0.78 to represent the probability that the plane departs and arrives on time. What is the next step? The next step is to make the representation. As for our representation, let us have the probability of A given D be the probability that the plane arrives on time given that it departed on time. After the representation, what is the next step? The next step is to make the solution. So we have the probability of A given D equals the probability of the intersection of A and D over the probability of D. By substitution, we have 0.78 over 0.83, which is equal to 78 over 83 or 0.9398 or 0.94. We can now finally make our conclusion, which is the probability that the plane arrives on time given that it departed on time is 78 over 83 or 0.9398 or 0.94. Before we answer the second problem, let us go back to our given. Again, we have the given as P of D equals 0.83, P of A equals 0.82, P of A and D is equal to 0.78. Let us make the representation for the second problem. We let the probability of D given A be the probability that the plane departed on time given that it has arrived on time. And now let's have our solution. The probability of D given A is equal to the probability of the intersection of A and D over the probability of A. By substitution, we have 0.78 over 0.82, which is equal to 39 over 41 or 0.9512 or 0.95. For our conclusion, we have the probability that the plane departed on time given that it has arrived on time is 39 over 41 or 0.9512 or 0.95. You may express your answer in decimal form, fractional form, or in both forms. I hope through this video, you'll learn something about conditional probability. And if you like, you may answer the next problem and comment your answers below. The problem states that the probability that a married man watches a certain television show is 0.4, and the probability that a married woman watches the show is 0.5. The probability that a man watches the show given that his wife does is 0.7. Find the probability that number 1, a married couple watches the show, number 2, a wife watches the show given that her husband does, and number 3, at least one of them watches the show. Enjoy solving!